different speeds depending on the number of antennas that you're going to have on the router. And remember, some of them are not really 100% AC, are like by IEEE, and those are the ones that either not adapting the complete, they're adding things from themselves. For these, you have to make your network card and your router must match 100%. So if you buy a D-Link, your NIC card has to be a D-Link too. If you buy a Netgear, your network card has to be a Netgear also. So be very careful with that. Majority of us is using this one, the G. The A is hardly used, only between basically side to side, you know, between buildings, they use A. Right, a directional kind of line of sight between buildings. Inside, they are using G most of the time. By the way, the N and the AC range, especially the speed, is going to degrade big time with distance. Because first of all, higher frequency, less energy. So penetrating or traveling a longer distance is going to be an issue. So this will have probably a little bit bigger, wider coverage, but more noise. And the reason for that is 2.4 gigahertz frequency spectrum is busy. Too many people on that spectrum, and too many devices work on this unlicensed, because this is an unlicensed spectrum. So like all the medical wireless equipment work on that, your microwave oven work on that, your cordless phones work on that, your Bluetooth work on that. So anything wireless in the house is working on the 2.4 gigahertz. That's why the 5 is better, because it's quieter, less noise, because you're far away from that 2.4 gigahertz. It's still unlicensed band, it can be used, but it's much quieter because most of the equipment we have uses the G, the 2.4 gigahertz. Yeah.
Devices need to be able to receive the 5 gigahertz signal, right? Or can it just receive any?
If it's an ABG, then it has to receive the 5 and the 50. Yeah.
How all the wireless devices I have at home work when I use the 5 gigahertz signal?
You do?
Yeah. Because I have an 502.11n.
Yeah. You have the N?
Yeah.
Yeah. The N will use both the G and to achieve this. The 2.4 and the 5.
What I'm saying is the 5 gigahertz, I can't get it working on most of the devices.
Oh yeah, because not all of them support the A. That's the problem. Yes.
Oh,
Yeah. Majority supports BG or G only, and very few that will have the A support. That's why. And if they don't have the N, then forget it. If they have N, then yes, they have to support 5. Yeah. But if they don't have the N, majority of laptops, if it's not N, then it's B and G. That's it. Okay. I haven't seen any laptops comes built in with ABG. Few. You can get them, but very few. But the majority are BG, and the A is left for basically. But if you have N, then you're okay. You have 5 because it chooses both.
These 5 Blu-ray players got Netflix on it and stuff. How they're feeling, you know, we don't have high speed DSL, straight DSL.
Yeah.
The movie just stop.
Oh yeah, of course.
So I'm just wondering if you need help to hardwire it.
Yes. Hardwired? Yeah. Or you get your internet through a microwave link from another company. Yeah. Yeah.
It's very expensive.
Very expensive, yeah.
What's the wattage on
They are very, they're limited. I think the wattage on the, I'm not sure about the A. I think the G right now limited to about 50 milliwatts, 50 to 70 milliwatts. Yeah, not much, no. Yeah, that's all regulated by FCC regulations, so really cannot go beyond certain wattage.
Even with an FCC license, I can't boost it?
Yeah, if you have them, yeah, you can. And the way that you bump up the wattage is that some of them you are able to tune to control the wattage. Not all of them. Some of them you are, like Cisco ones, you are able to go in and change the power all the way up to 100 milliwatts, you know. So you can fine tune the amplifier. And then that's number one. Number two, you can put amplifiers in, and then you can put high gain antennas, so you can take the antenna out and put the high gain antennas. But there's formulas that you have to plug in to, if you're gonna put it outside, you know, you gotta make sure you're within the limits of the FCC. So you have to take in consideration the gain of the antenna, the loss of the cable, depending on the length of the cable you're running.
Right.
Yeah, and then the power output and all that.
Yeah, what is it? 70 centimeters, you're allowed 15 milliwatts.
Which one?
70 centimeters.
7 centimeter? 70
centimeters.
Centimeter? Yeah, those are different.
440 cable.
Yeah, these are totally different. Yeah. Yeah, this is just whatever comes in on that standard. I know what you're talking about. Like, that's on the microwave side. And that's what they use, line of sight for microwave. So one of the technologies they use on the B and the C, on the N and the AC, they both use MIMO, multiple in, multiple out, which means that they are able to simultaneously use all three antennas and to receive, okay, and to transmit. The other thing that they use is called beamforming. Beamforming means that you are able to, instead of having a single antenna with a radiation pattern that is omnidirectional like this, with the digital signal processing, they are able to do some play around with the signal and the phase shift. They can fine-tune this so that the beam will form into something like that. So, for example, if you're trying to target an area there, instead of wasting all this energy right here, which is wasted going to nowhere, you're only utilizing this part, then I'm going to utilize this extra part in here and beamform it and extend. With this one, with beamforming, you can extend the range dramatically for wireless access points, okay? So beamforming is a standard on the 802.11 AC and also on the N, plus the MIMO, the multiple in, multiple out. Now, in terms of modulation types, you guys don't have to worry about that. That's how they compress the data. They use the orthogonal frequency division multiplexing, OFDM. DSS, I think, yeah, spread spectrum, direct sequence spread spectrum. So